Welcome back, and today we're going to be looking at servos. Now, right from the beginning, let's just have a quick look at one. If you've ever bought an Arduino kit or one of the robot cars, you tend to get one of these servos included in the kit. Little cheap plastic servos, but they're absolutely brilliant. And so that's what we're going to look at today, how to control these servos. Now, a servo is different to any of the other items that we've looked at so far in that they require a library to be installed into the Arduino IDE. So part of this tutorial today we'll look at how you get that library installed. We'll then look at how you include the library in the sketch, because it's one thing to include it in the IDE software, but it's another thing to actually get it to work within the sketch. And then finally, when we've done all of that, we'll actually use the servo library to control the movement of our servo. So that's the lesson plan for today, so let's get on with it. So I've got the IDE started up, and as you can see, I've just got a blank sketch in front of me for now. And what we're going to look at is how we load a library into the IDE. Now, even before we do that, it would be quite useful to know what a library is. So if you can imagine, when we've looked in the Arduino reference, let's just pull it up now. In the language reference, we've got various functions that do different things. Now, the problem is that we have all of these functions, but there's not a function there to control every single sort of component that we could come across. When you're programming, you will come across a lot of different items. It could be servos, it could be touch screens, all sorts of different items, and some of these things can be quite complicated to connect to. So very often some very nice person, a good programmer, will figure out how to connect to a particular item, and they will write a library that we can then install into our IDE that allows us to call on some functions that they've created and send commands to a particular component in a relatively easy way. If you think about this servo that we've got, it's supposed to be sent what's called a pulse wave modulation signal, all sorts of things. I'm not sure of the specs of exactly how it works, but I could get the specifications and sit here and spend hours and hours trying to work out how to do it, and there's many times when I've actually had to do that. But it's much nicer if someone's already taken all the time to do it and has taken most of the work out of the job. So the way to install a library, if you've got your IDE open, you go to Tools, and then you go to Manage Libraries. Click on that one, and up comes the Library Manager. And when you're trying to install a library into the IDE, the Library Manager is the best way. Now, there is one odd thing about the servo library. I cannot remember for the life of me whether it comes pre-installed or not. I'll be honest, I've been using this IDE for so long, I just can't remember, and I don't want to sort of try and ruin what I've set up. So we'll do it as if it's not installed, and if it is installed, you'll see what will happen. So all I'm going to do is type in servo. Press return, wait, and there we go. This is the servo library, and you can see in my case it's installed. Now, if you notice to the right on mine, there is an update available, and if I go and select version, I can see that a new version 1.18 has come out since I installed this version. So maybe it's time for me to install a new version. Now, if your server, if you've done what I've done and it's come up with installed, fine, carry on. If, however, it's come up with something like this where it's asking you to install, then just click on install and all will be well. Once it's it takes a couple of seconds to do its stuff, but once it's installed, close this down and you can then get on with using the library. So that is how the library is installed. Now we're going to get on and start to look at a sketch. Before we start looking at the sketch in detail, one other thing you need to know when you've installed a library is that the lovely people who write these libraries also write example code. So if you now go to File and then down to Examples, you can see I've got rather a lot of libraries installed in my IDE, but if I keep working all the way down, eventually I will come to Servo. And here is an example. If I click on the example, it will actually have all the code in here. There's even a link to where you can find more information about this particular example. But it's one of those things that very often, if you get stuck on any of these lessons and you're using a library, if you go to the examples, very often there's a way that you can figure it out from the examples provided. Now we're now going to sort of look at the sketch that I've created. I've tended to do my own examples. That's because for those who are doing the robot car project, I'm trying to make sure that none of the lessons overlap each other. So for instance, in this lesson we're going to be using pin 12. I'm using pin 12 not because pin 12 is a special number, but I know of all the other components that we've added to the car so far, none of them use pin 12, hence the reason for using it. But this could be basically any digital pin, preferably from pin 2 to pin 13. So let's start to look at the sketch. The first thing we see here is that we have to include servo.h. Now I'm not going to go into the technicalities of how a library is written, but the .h file is basically a file within the library that gives the Arduino IDE a list of all the possible functions that can be called from within that library. So this is saying to our IDE, I want you to include the servo functions within this sketch. Now you might think, well, why do we have to write this in here? Well, it's quite simple. If we go back to File and Examples, if you notice, these are all custom libraries that I've installed. Now if we didn't specify which libraries we wanted to use and instead it installed all the libraries by default, it would mean that for a very simple sketch in my IDE it would be including all these different libraries. It would take forever to compile, and most of what was compiled would be functions that would never ever be used. So this little line here says that in this particular sketch we're going to use some functions from the Servo library, so include them within the sketch. Now then we've got a couple of global variables here. You'll have seen this before, and if you don't understand what a global variable is, there is a lesson in the C++ tutorial on the Digital Town website that can explain the difference between global and local variables. So my servo pin equals 12 because we're using pin 12. I'm using a constant integer, that is an integer that's value cannot be changed within the program because I want that servo pin to always be 12. Now what I've also done is created an integer called servo position, and this is going to be a value that I send to the servo to tell it what position I want the servo to move into. The next item here is something that I've not sort of taught on before because this is the first session I've done with a library in, but here we have an object. So we've got the servo library, and it's a bit like calling a variable a name. So in this particular instance I'm calling my servo, bizarrely, my servo. Nothing like a creative name. Now if I'd got a number of servos, what I could do, I could have had servo 2, could, type a name in, call them what you want, but obviously for each servo that I create, I will also need a servo pin. For this example, we're only using one servo, so we only need the one line. Now in the setup, I've got the standard setting up the serial communication. I've done that because in the sketch we'll be using the serial monitor to see the instructions being sent through so that we can check that our servo does actually move as we're expecting it to. Now when we attach the servo, again this is now saying that I'm going to use the attach function from the servo library, but because I'm calling this my servo, it's now saying that this object, my servo, is now going to use the attach function, and it's going to attach itself to my servo pin, which is pin 12. In very simple terms, it means that my servo that we've created is going to be controlled by this pin. It's as simple as that. Now the Arduino is going to be sending out information to this particular pin, and if you remember the lessons on digital write, if you did that one on the Digital Down website, you'll remember that before we could send out information we had to use pin mode for the pin. Now in this particular instance we don't, because that's all taken care of within this function in the servo library, so we don't have to worry about that. So that's the main setup, and now bizarrely we get to the very, very simple bit. So what I've started off is I've set the value of servo position to 0. Now the servo will move, these particular servos that we're using, they only move 180 degrees, basically half a turn, and the value that you can put into them is from 0 to 180. Simple as that. So what I'm going to do is I'm going to print the serial to the serial monitor the position, the number that we're passing, and then what we're going to do is send that instruction to the servo. So my servo, that servo object that we've created, we're going to use the write function. So we go dot write, and then we send our value, which is the servo position. So the first value that we'll send to the servo is 0. Then we're going to have a delay for 1 second. Now just a little bit of information about delays or things like when it comes to servos. When the instruction's sent to the servo will start to move, but it is an electric motor and it does take a little bit of time. Not long, probably less, well, under a second normally. But one of the things you have to be careful of is if you send an instruction to a servo and then immediately put another line underneath with another distance that you want to get, you want the servo to move to, it won't even finish moving to the first servo position before it moves to the second servo position. So in this instance, to make sure that we can see what's happening, I'm putting in a delay of 1000, which equals 1 second. Then what I'm going to do is I'm going to create make the servo position equal to 180, and that means that the servo is going to swing all the other way round. So it's going to go from one extreme of 0 over to the other extreme. Again, we're going to serial print it, we're going to write it to our servo. So it's a bit like we print that information to the screen or we write that information to our servo, and then we're going to wait for 1 second again. Then there's a little example that will follow that of how we move the servo very, very slowly, because obviously when I've sent this instruction, the servo will do its best to get to that new position as fast as possible. Now sometimes we don't want the servo to move that fast. We might want it to move slowly for some reason. When I've built items for model railways, sometimes when I'm moving something, I don't want it to go as fast as possible. I would like it to go a little bit slower, and this is an example of how to do that. So what we're going to do, we've got a for loop. Again, on the Digital Town website, there's an explanation of how to use a for loop. So we're going to start with a value of 0. So again, the servo is going to move all the way to its left hand side. And then we're going to tell the servo to keep moving while it has a value less than 180. And then we're going to increment the value by 1. So if you can imagine, we're going to send a signal to our servo to move to 1 degree, 2 degrees, 3 degrees, and in between each movement I've put a very short delay. So what you'll see when we run this sketch is that first of all your servo will move to the left, then it will move 180, so it'll go to the right, then it will go back to the left, and then it will slowly work its way to the right. Then what it will do, it's going to go back to the left again, back to 0, and it's going to work its way across. But this time, instead of adding 1 each time, we're going to be adding a value of 10. So instead of running very, very smoothly, this time it's going to run in a series of more distinct steps, and there's going to be a slightly larger time delay between each step. Then what I thought I'd better do, just as an example, is we're going to do the opposite. We're going to start at 180 and we're going to move back to 0, and we're going to be going again 10 steps at a time. That's the plan, that's the sketch, and if I upload it to my Arduino, I'll just plug in my servo. I unplugged it while I did the lesson because it can get a little bit noisy. So my servo is now starting to move. You can see the different values that I'm sending across, and I'll do a little video in a minute on my phone just to show you what's going on. So here is my rather dodgy desktop setup. As you can see, this is the sort of servo I'm using. I'll just try and get that into focus. But of course, if I rotate that, it's pretty difficult to see. So let's put that to one side. And what we have here is part of my robot car, which, if you can just about see that, has got the servo fitted inside it. You can see how it's wired over to my Arduino, and on the Digital Town website there is actually a schematic to show you exactly what the wiring should be for this. I'm just uploading the code now, and he says, hopefully. There we go. Let's grab hold of this because it's going to start jumping. So as you see, that's it running through the code. It goes to one extreme, then the other extreme, then it moves slowly, quicker, and then starts again. It's jumping all over the place. These things are not the easiest to hold down. So that's the code actually in action. Let's get back to the IDE. So if you're not still traumatized from that terrible phone video, I just thought I'd better go through the wiring with you. As you would have seen, my servo was attached to an Arduino with some wires stuck into the plug. It was basically this setup here. So the orange wire, the signal, was going to pin 12. The red wire, 5 volts, is going to the 5 volt pin on the Arduino, and the brown wire was set to go to ground. Now if you're using the sensor shield, mine unfortunately is attached to my robot car at the moment, so I wanted to keep that out of shot, but it's a piece of cake. It's basically take the plug that is on the end of the servo cable, make sure that the orange wire is at the front on the S line, the brown is at the back on the ground line. That's it, you're plugged in. So before I torture you with yet another video from my phone, let's just have a look at the final sketch. So this final sketch doesn't really teach you much, but it is actually very, very useful. It's a sketch I use a lot. So let's just go through it. So as before, we're including the library. I've got my servo pin 12, my integer that's going to give my servo position. We've set up the servo object, and then just so you can see, there's nothing in the loop. That's because this set of instructions only runs once. So once the servo has been attached, it goes to position 0, then it goes to position 180, back to position 0, back to 180, and then finally it finishes up at position 90, where the servo is in exactly the halfway position. Now I'll explain a bit more in what is probably going to be one of the most traumatic phone videos you've ever seen. So hold on to your hats. So this is the other example sketch. You've noticed I've actually attached my servo to the front of my car just to stop it jumping all over the place. But what this does when I start the sketch is it will just cause the servo to rotate from one side to the other a couple of times. And then what it does is it goes to 90 degrees. And this is just to check that I've got the servo set in the right position. It's very easy with these servos to attach the units to it, but actually to have attached it while the servo is at position 0 or position 60, so that when you run your code, you suddenly find that your ultrasonic sensor is pointing off in an odd direction. So I've included the servo setter code, which once you've run it and the code has ended, that is the position to screw the bracket together onto the top of your servo. Well, if you're still here and not too traumatized by that video, we'll just have a recap of what we've done in this lesson. So we've controlled a servo. We've installed the servo library into the IDE. We've learnt how to put a library into a sketch, how to include it in there. And we've used various functions from the servo library to control our servo. Servos are very, very useful. They're one of those things that I've used them from model railways, robot cars, even my cat washer project, which is something that squirts water at cats to stop them pooping in my back garden. All interesting stuff that you can build with a servo. So very, very useful items, and I hope the video's been useful to you. Again, apologies for the absolutely appalling phone videos, and hope to see you next time. And if you did enjoy it or weren't too traumatized, click the like and subscribe button. Thanks again.